Hello and welcome back to AGT STEM. Today we're going to be watching a video about ytterbium. So without further ado, let's hop to it.
Neil and I were given a huge lump of metallic ytterbium, and so we felt it was time to update our video about ytterbium. You will have seen Brady and Pete going to Ytterby, where the elements or the minerals containing ytterbium were first discovered.
So, we've reached the top. Where are we?
Look up yonder, to the left.
Oh, wow.
So Neil and I felt that this lump of ytterbium justified making a new video, though we were not terribly hopeful that it would be very exciting. And we were totally surprised. It was fantastic. Really nice sparks and colours and some quite nice salts as well.
Like it.
So let's begin. The mineral that ytterbium was discovered in was found in Sweden, but it was actually isolated in Switzerland, in Geneva, by the Swiss chemist Jean-Charles Galissard de Marignac. Quite a fancy name.
Easy for you to say.
Yeah. And when he died, there was a memorial lecture in his honour by the Chemical Society, the forerunner of the Royal Society of Chemistry, honouring this really famous chemist. It has a nice picture of him as well, but I found it really quite fascinating because it described his lab, the laboratory in which he so zealously laboured for upwards of 30 years, and which was the birthplace of his most important investigations, is described as a damp and gloomy cellar, more like the den of an alchemist than the workroom of a modern chemist. Here he worked alone without assistance. Nowadays, professors have whole teams of students and other researchers. He was doing it all himself. He was analysing an oxide from one of the elements in this mineral called gadoliniite. This was really painstaking work, heating things up, dissolving them up again, then trying to isolate different compounds. And he found an extra oxide that he was not expecting in what was meant to be a pure element or pure oxide of an element. And he published a paper. He was from Geneva, so it was in French, which was called Sur l'Ytterbium, nouvelle terre contenue dans la gadoliniite, which means about ytterbium, a new element or earth contained in gadoliniite, which is the mineral that came from Ytterby. This is a paper discovering a new element, and it's 4 pages long. The really key point was that he measured the atomic weight, or tried to estimate the atomic weight of the element. He had just a tiny amount of this oxide that he got, and he worked out that, and I won't read it in French, I will just translate it, the atomic weight of ytterbium, and he chose the name ytterbium because it came from Ytterby, was either 115 or 172.5, depending on whether the formula of the oxide was YbO or Yb2O3. Turns out that it is Yb2O3, and his value of 172.5 is close to the modern value of 173, which I think is amazing. Here he is in a dark, damp cellar producing results that are pretty close to the modern values. So I'll tell you a bit more about de Marignac, but let's get back to the chemistry and our lump of ytterbium. Before we look at the metal itself, it's worth looking at one of the salts. And we were given a sample of ytterbium chloride, and Neil has a nice set of reagent bottles with solutions of different salts. And so we started putting some of the ytterbium chloride into these salts. we began with potassium carbonate, and there was a nice white precipitate, almost certainly ytterbium carbonate. Then came
it sort of looks like that instant snow stuff that's like fake snow. That's what it reminds me of when you look at it.
Almost certainly ytterbium carbonate. Then came potassium chromate, which is yellow, and there was a really nice precipitate of yellow ytterbium chromate. I'd really quite expected that because most chromates are insoluble. We then tried sodium sulfide, which didn't produce any precipitate at all. Brady thought was quite excited. Professor was wrong. We got nice precipitates with potassium hydroxide and ammonium hydroxide, though Neil sniffed the ammonium hydroxide to check it was okay, and I don't think he'll be getting a cold for some time.
Ammonium hydroxide.
Is that still okay? Then it's not.
Yeah. Yes.
The final one, which Neil thought would work, was potassium iodide. I said it wouldn't.
And now the one that Martin guarantees is going to be disappointing. Staked his professional career on this one.
And nothing happened. So Brady felt that I was justified in being a professor.
You get to keep your professorship.
We liked the potassium carbonate and dichromate so much that we decided to do them again a little more precisely, with Neil dropping in the ytterbium chloride drop by drop so that you could watch the precipitate forming in a more artistic manner. The chemistry is the same, but the mixing is slower, so the reaction takes longer. We then went to our lump of metal. We were given this lump of metal by our friend Anthony Lipman, whose company buys and sells metals. And I think this was a sample from which people had drilled out little bits and perhaps sawn bits off. So it had all sorts of quite interesting markings. So it was almost like a work of art in its own right. But a lump of metal isn't really very useful for doing chemistry with. So poor Neil had to file off the metal to get some powder. And the first thing we tried to do was to dissolve the powder in hot water. It is claimed that ytterbium will dissolve in hot water to give the hydroxide and hydrogen. So Neil heated it up. There was a little bit of hydrogen, perhaps. I persuaded Neil to jazz it up with some hydrochloric acid. And whoosh!
Oops, so easy.
Big bubbles of hydrogen, and it dissolved.
Got some hydrogen now.
Unfortunately, the test for hydrogen didn't work. It almost looked as if Neil was extinguishing a splint with hydrogen, but I don't think that was what was actually happening. So what was really exciting was Neil dropping the powdered ytterbium into the flame of a Bunsen burner. There were
It looks like fireworks.
fireworks
Yeah.
everywhere, bright sparks. And I was quite interested because at the end of the sparks, as they were flying outwards, it seemed to be orange. But I think that might be red hot particles of the material as they flew away. And there was a slight greenish tinge. But the amount of light was really impressive, almost washed out the image from Brady's camera. And then I'd read that if you mix ytterbium with polytetrafluoroethylene, PTFE, you can get a bright emerald green colour. So 2 days ago, I bought a packet of powdered PTFE online. It arrived just in time. Neil mixed some of this white powder together with his filings of ytterbium and dropped it into the Bunsen flame. And indeed, you did get a much brighter green colour.
I think it's greener.
I think that the green colour must be due to some form of ytterbium fluoride in a highly excited state. But exactly what it is, I have no idea. Perhaps some of you, the viewers, know exactly what it is. But it was really exciting. Let's go back to Marignac. And the thing that's interesting, that he isolated the oxide. He never actually isolated the element. And most surprisingly, metallic ytterbium, like we've got, was first isolated in 1953. So we're just about the 70th anniversary of the isolation of metallic ytterbium. So unfortunately, poor de Marignac never saw these wonderful colours from Bunsen burners that we did. Nevertheless, I think it's really important to stress that discoveries of these elements are really quite an international effort. The mineral was discovered in Sweden. It was transported to Geneva, where the element was discovered by a Swiss chemist. And his discovery was recognized by all sorts of honours, including the Davy Medal of the Royal Society of London. So he was recognized very well for his achievements.
Thank you so much for watching, and we'll see you next time. Stay smart. Bye!